Hi everyone in Algebra 2B. Today we're going to be going over the new lesson 107. So there's a couple equations and formulas you need to know for this one. So this is something that I would definitely keep in my notes. So anytime that the word original number comes up, that's going to be 10t plus u. And anytime they say reversed or new number, you're going to use the formula 10u plus t. So those are two very important things that are a part of this lesson that you have to know. So make sure that you write these down somewhere for your in your notes. Now, and the other thing is that your T is going to stand for your tens digit, and then the U is going to stand for your units digit. So if you didn't know what those meant, that's what it's there for. So we're going to start by going through just the examples, and then I want you to try these on your own before you actually do them with me in the lesson. So it says the sum of the digits in a two-digit counting number is 11. So that means just adding your two digits, your tens and your units digit, you're going to get 11. So you're going to do t plus u is equal to 11. Then it says if the digits were reversed, the new number, so this equation, is 27 greater than the original number. So these are going to be where your two formulas come in. So it says, again, if the digits are reversed, the new number, so 10u plus t, is 27 greater than the original number. And the original number is going to be 10u plus t, or 10t plus u, and it says 27 greater than that. So now what you have is basically just two equations that you're going to solve for what u and t are equal to. What you're going to do first is I would bring this 10t over to the left, bring the u over to the left, and you would be left with 9u minus 9t is equal to 27. Now you could just do substitution or elimination at this point because you have this equation here that you could solve for u and do u is equal to 11 minus t. I'm going to also show you that you can do elimination too, so don't worry, I'll show both on the next problem. So u is equal to 11 minus t, so I'm going to do 9 times 11 minus t minus 9t equals 27. When I distribute, I'm going to get 99 minus 9t minus 9t is equal to 27. Now I have to bring this 99 to the left-hand side, or right-hand side. I need to combine the negative 9t, so that would be negative 18t equals 27 minus 99, which is negative 72. Then when I divide that by 18, negative 18, I get that t is equal to 4. Now, if t is equal to 4, then I can plug that into here, and I would get u equals 11 minus 4, which means that u is going to be equal to 7. And the question is, what is the original number? Well, if I multiply the 4 times the 10 times 4 is 40, and then you add the 7, your answer is going to be 47. And that is your result. So you need to know both of these equations in order to complete this problem. So that's going to take some memorization. So now we're going to look at 107.2. On this one, I'm going to use elimination instead of substitution. So I'm going to keep my notes there. And it says the sum of the digits of a two-digit counting number was 9. So again, that's the tens and the units digit. So t plus u equals 9. Then it says when the digits are reversed, again, the new number was 45 less than the original number. So new number, 10u plus t, was 45 less than the original number. So 10t plus u, and then minus 45. So now this time I'm going to end up doing elimination. So I'm going to move the 10t to the other side, I'm going to move the u to the other side, and I'm going to rearrange it. So I have negative 9t plus 9u is equal to negative 45. But look at that. All three of these numbers are divisible by 9. So what I'm going to do is actually divide this whole equation by 9. And I would get negative t plus u equals negative 5. And now I can easily do elimination with my original equation of t plus u is equal to 9. Notice that the t's now cancel, and you get 2u is equal to 4. So my u is going to be equal to 2. Now it says, now I need to solve for what t is equal to. So I have t plus 2 equals 9. Well, that means t is going to be equal to 7. Again, they want to know what the original number is. So you multiply the t times 10 and then add the u. So if I multiply 7 times 10, I get 70, and then I add 2, and my answer would be 72. And that concludes your new problems from lesson, or your examples from lesson 107. I want you to attempt numbers 3, 4, 5, and 6. And then when you're done, I would unpause the video so that you can do them with me. So for number 3, it says the sum of the digits in a 2-digit counting number was 15. If the digits were reversed, the new number is 9 greater than the original number. What was the original number? So when it says the sum of the digits, you do just t plus u is equal to that number, which was 15. When it says that the digits are reversed, you're going to use the formula 10u plus t. It says the new number is 9 greater than the original. So the original number, again, is 10t plus u, and it's 9 greater than that. So now if I bring the 10t to the other side, bring the u to the other side, and if you rearrange it, you would get negative 9t plus 9u is equal to 9. And again, just like on that last problem, it makes it a lot easier if you simplify this equation. So you should notice that all three of those numbers are divisible by 9, which means that you end up with negative t plus u is equal to 1. And that would easily eliminate with t plus u is equal to 15. That would give you 2u is equal to 16. So therefore your units digit is going to be equal to 8. Now you can take that 8 and plug it into here. So that would be t plus 8 equals 15, which means that t is going to be equal to 7. The question asks us for what the original number is. If the tens digit is 7 and the units digit is 8, your number is going to be 78. Now moving on to number 4, it's also a new problem, very similar to the last one. It says the sum of the digits of a 2-digit counting number was 13, which means when you add the tens and the units digit, your result is 13. Then it says when the digits were reversed, the new number, so again, new number is always 10u plus t. It says was 9 less than the original, and the original you should have listed as 10t plus u, and then 9 less would be just minus 9. So again, the process is pretty similar every time. So I'm going to bring the 10t and the u to the other side. And I'm going to rearrange it as negative 9t plus 9u is equal to negative 9. Now I'm going to show you that if you don't simplify, it also works. So I could actually just do substitution. So I'd solve for t and get t is equal to 13 minus u. So I have negative 9 times 13 minus u plus 9u equals negative 9. This does make the problem a little longer. So you have 9 times 13, which would give you negative 117 plus 9u plus 9u equals negative 9. Now I'm going to move the 117 to the other side so that I get 18u is equal to 117 minus 9, which is 108. And when you divide that by 18, you get the u is equal to 6. Now, after you know the u, I can solve for t by doing t is equal to 13 minus 6, which would give me t is equal to 7. So in this case, the tens digit is 7, the units digit is 6. So my original number is going to be 76. Now I wanted you to attempt numbers 5 and 6 as well, just so you can work through them with me because they are pretty new. So for number 5, it's a 70% markup on the selling price brought the selling price to $1,400. What did the shopkeeper pay for the item and what was the markup? Okay, so for number 5, it says the markup was 70%, so 0.7 of the selling price. And they actually give us the selling price to $1,400. So that means that the markup would be 0.7 of 1,400. So 0.7 times 1,400 would give us our markup is going to be equal to $980. So they asked us for that. So it's one of your answers. The equation that we're going to use is going to be selling price equals purchase price plus the markup. So I already know what my selling price was. It's $1,400. I don't know what my purchase price is, but I do know that my markup is $980, which means 1,400 minus 980 gives us the purchase price of $420. And that is your result for number 5. Now lastly is number 6. So for number 6, what I'm going to do is you're going to start by solving for one of the letters. And in this case, I'm going to solve for x in the bottom equation. That is going to give me x is equal to positive 3z minus 11. I'm going to use that then to plug into my top equation where I see an x. That will give me 2 times 3z minus 11 minus y equals negative 6. I'm going to distribute the 2 so that I get 6z minus 22 minus y equals negative 6. I want to arrange it so that it's in the same format as that middle equation. So I'm going to move the y out in front and then do plus 6z equals, I move the 22 to the outside, which gives me 16. And now what I want to do is I'm going to look at this equation here and this equation here and do elimination. And I could either eliminate y or z. So if I eliminate y, I'm going to multiply this equation by 3. So that would give me negative 3y plus 18z is equal to 16 times 3, which is 48. And I'm adding that to the 3y plus 2z equals 12. So when I add those together, the y's cancel, and you get 20z is equal to 60, which means that z is going to be equal to 3. Now that I know what z is equal to, I can take that and plug it into here. So that would be x is equal to 3 times 3 minus 11. So x would be equal to 9 minus 11, which would give me negative 2. And lastly, I just need to solve for y. And now that I know x, I could plug it into here, or if I wanted to solve for y with this equation, I could plug in my z here. So 3y plus 2 times z equals 12. 2 times 3 is 6, so you're going to subtract 6 from the other side, and that would give you 3y is equal to 6, which means that y is going to be equal to 2. So your answer is going to be x is negative 2, y is 2, and z is equal to 3. Now again, this concludes all of the new material from lesson 107 that I wanted to go over with you. I hope that you took some notes in there, and then in the comments of this video is where you're going to put your questions for 107A. I hope you guys all have a great day. Bye.